So we're going to continue with video 2 on this inverses and one-to-one functions. So we've got a graphing problem here. I started to graph out, and let me just start all over here. So I'm going to go ahead and regraph this out. So we got these ordered pairs up here. We've got 2, 1, 5, 1, 2, negative 4. Let's graph those out. So from 0, 0, I'm going to go over 2 and up 1. From 0, 0 there, I'm going to go over 5, 3, 4, 5, and up 1. And then I've got 2, negative 4, so I'm going to go over 2 and then down negative 4. 1, 2, 3, 4. Once I have those, it says they're vertices of a right triangle there. So see if you can connect those. And it's supposed to be the vertices of a nice right triangle there. So we're supposed to find the inverse of this relationship and then graph the two relations. Alright, so we know how it's going to go, right? So if these are all x, y, so I'm going to list them down here. We've got 2, 1, we've got 5, 1, and we've got 2, negative 4. So let's find the inverse one of those. So that means I could swap them. I can say 1, 2, and 1, 5. And our last one here, swapping the x and the y, I get negative 4, 1. So now we're just going to graph those. So I've got 1 and up 2. I've got 1, 5, and up 5. And then I've got negative 4. And again, I can go ahead and just graph those out. So I graphed out 1, 2, and I graphed out 1, 5. And then I graphed out negative 4, 1. So let's connect those. Didn't do a great job there, but not bad. So hopefully you can see the relationship here with the inverses here is that we say that it's actually, let me draw the line in here. There's a line in here at x equals y. So I'm going 1, 1, 2, 2, 3, 3 as I do my ordered pairs in here. And we say that it's just reflected over this line. So negative 1, negative 1, negative 2, negative 2. I just kind of wanted you to see this picture here. So they're just reflected over that line. So this point right here is reflected over this line. And you can see this point here is reflected over here, which means they just have, you know, the y's and the x's are just swapped because y equals x. So this line here is y equals x. And we just reflect them over, and that's its inverse. But these are the ordered pairs of the inverse function right here. So now let's go ahead and find the inverse of each function. So the way we want to do this is, what your steps here are, is you want to go ahead and you want to rewrite this as a y equals statement. So let's do that. Let's rewrite this as a y equals statement. So if I do this, this becomes y equals 3x plus 2. So then we can simply just go ahead and solve there for x. So I'm going to get it as an x equals, so I can subtract 2. I can divide everything in there by 3. So if I divide every single term in here by 3, I'll just do it. So then I end up getting x equals 1/3 y minus 2/3. Alright, so then your last step here is, well, second to last step here, you can swap the x and the y because we want it in the right notation here. And then we're going to replace the y here with actually the notation here of what we want. So let me do that. Delete that out of there. So this becomes, let me rewrite this. Let's do a different color there so you can see it. So it becomes f of x equals 1/3 x minus 2/3. So let's do another one of these. So coming down here, and that's, well, I should have put the inverse notation in there. So let's come down here and let's do another one. So if I come down here, you want to go ahead and rewrite this as y equals, instead of f of x equals 3x squared minus 1. Then you want to solve for x. So you've got to add 1 to both sides because you've got to get the x all by itself. Divide everything in here by 3. So we end up getting x squared equals 1/3 y plus 1/3. And then we want to go ahead and take the square root because we have to get rid of that x squared there. So now we can take the square root of both sides. So we simply end up there with x equals the square root of 1/3 y plus 1/3. And so after we've done that, we can go ahead and remember, because we took the square root there, we actually have a plus or minus on the outside here. So now what do? We go ahead and we switch the x and the y because it's inverse. And then the last thing we do is we replace that notation there, and we say the inverse of f of x is equal to plus or minus the square root of 1/3 x plus 1/3. All right, and then got a new one down here. Again, switch, go ahead and replace the f of x there with y. So I did that. What do we do now? Now we're just going to go ahead and solve for x. So what do I have to do that? I have to multiply both sides here by 2. Maybe I'll do that in a different color. So I get 2y, because the 2's here on the right hand side are going to cancel each other out. So these get canceled out. So 2y there equals x to the 5th minus 3. Go ahead and add 3 to both sides. And because it's an x to the 5th, how do you get rid of a 5th power? Well, how would you get rid of a squared power? You took the square root, right? Well, how do you get rid of 5th power? You have to take the 5th root of both sides. So let's go ahead and let's take the 5th root of both sides. So remember how that's written, you go a little 5 out there. So we're going to end up here with x equals the 5th root of 2y plus 3. All right, and that's a 5th root. All right, so then I'm going to give us a little bit more room here. So then what else we want to do here is finish this up a little bit. So we're going to swap the x and the y. And then after we've swapped the x and the y, we want to go ahead and write it in its final notation, which is the inverse notation. So if you kind of want to know what the steps are, you want to go ahead and replace f of x with y. Second step, you want to solve for x. Third step, once you get an x equals, then you want to switch x and y. And then the fourth step, you want to replace y with the inverse notation, inverse of f of x. All right, so that's the way you want to do those. So now your homework is going to be on page 230. You're going to do 2 to 20 and 32 to 40, and only the evens on all of those.